Welcome to session 3 of Unit 2, and in this session we'll be looking at enthalpy. By the end of the session, you should be able to explain the term enthalpy, calculate the enthalpy change of a given chemical reaction, and state the thermodynamic standard conditions of pure substance. We have seen up to this point that a system can exchange energy with its surroundings, either by transferring heat or doing work. Using the symbol Q to represent transferred heat, we can write the total energy change of a system as change in energy is equal to Q, which is the heat plus work done. But we know our work done is equal to negative P change in volume. Therefore, we can substitute that into our overall equation, which gives us change in energy is equal to heat minus pressure times change in volume. Q has a positive sign if the system gains heat, that is an endothermic reaction, and a negative sign when the reaction is exothermic. Now, what is actually endothermic reaction? It is a reaction in which the system absorbs heat from the surroundings. Taking for instance the melting of an ice, definitely the system will have to absorb some energy to break the bonds holding the ice together. So you realize that Q will have a negative sign if the system loses heat to the surrounding, that is exothermic, and endothermic when Q will have a positive sign. Now, what is exothermic reaction? When we talk about exothermic reaction, it is when the system loses heat to the surroundings. The surroundings, having gained heat, get so hot and can even use in melting the ice. And that is to say that in this case, our change in heat becomes, or the sign we allocate for Q becomes what? Negative. The constant pressure lost is important in chemistry. Why? That is to say, the quantity of heat gain is equal to the change in heat energy or internal energy plus pressure volume, or the change in volume. Now, this change in volume is actually what we call enthalpy, represented as change in H. And also take note that enthalpy is an extensive and state function property as well. We made mention of extensive properties earlier on and intensive properties. Now, the enthalpy change for a reaction depends on the state of the reactant and that of the product. So, at constant volume, the change in volume is equal to 0, which will make our quantity of heat equal to the change in internal energy. And at constant pressure, our P will have a value of 0. So, therefore, our quantity of heat is equal to the change in internal energy multiplied by the pressure times volume. But our P is 0, which nullifies that to 0. So you realize that at the end of the day, our enthalpy of the reaction is represented by the equation change in H, or change in enthalpy, is equal to the change in internal energy plus the pressure times what? Volume, or change in volume. Now, let's take this example to illustrate our concept. The reaction of nitrogen with hydrogen to produce ammonia has enthalpy of negative 92.2 kilojoule. So what is the value of the change in internal energy in kilojoule if the reaction of 40 atmosphere and the volume change is negative 1.112 liters? So to solve this particular question, all you need is your change in internal energy plus pressure times the change in volume, and when you substitute this value, you'll get negative 92.16 kilojoule. Now we talk about standard conditions. What are standard conditions? In thermochemistry or thermodynamics standard state for a pure substance in a specified state usually is its most stable state at 1 atmospheric pressure and at a specified temperature, that is 25 degrees Celsius. 1 molar concentrations for all substances in a solution is referred to as what we call the standard conditions. So at standard conditions, we are referring to a concentration of 1 molar, a temperature of 1 atmosphere, and then a temperature of 25 degrees Celsius and a pressure of 1 atmosphere. A measurement made under this condition is indicated by the addition of the superscript 0 or not to the symbol of the quantity reported. So if we are going to write standard state conditions for enthalpy, let's say energy change, then we can write it to the power 0. If you are going to write it for standard enthalpy, we can say that H to the power 0. So that is how we write standard conditions for a particular quantity. And the enthalpy change measured under standard conditions, like I said earlier on, P equal to 1 atmosphere, T equal to 25 degrees, and then concentrations of 1 molar is called standard enthalpy of reaction and is indicated by the symbol this, as said earlier. Now, as part of your assessment or self-assessment and session review, the reaction between hydrogen and oxygen to yield water vapor has enthalpy of negative 484 kilojoule. So how much PV work is done, and what will be the value of the internal energy in kilojoule for the reaction of 0.5 moles of hydrogen with 0.25 moles of oxygen at an atmospheric pressure if the value of change in volume is negative 5.6 liters. So solve these questions so that you can embrace yourself with the calculations procedures. Thank you.